Alright guys, here I am again, Josiah Wizarike. I haven't done any video for over a year. On behalf of each one teach one, there are observations of unknown sciences that I've been coming across and looking into deeply. So for instance, in my culture we have something called ofo. An ofo is made from a special tree. I'm sure you know every tree is a tree in science or physics and electricity. They usually are not the best conductors, if you know what I mean. But that doesn't mean that when you put a foil around them, they won't be able to do something amazing for mankind. So let's dive into it. So the presentation here, should I call it an experiment? I'm doing it right off the bat. It's not complicated, straight to the point. So I have this rod here. This is a plexiglass rod for this experiment. I might not use this, but it's good for you to know. It's a part of gold leaf electroscope, bunch of experiments that's designed to detect not electromotive force, rather electrostatic force. Okay, so these are some of this to detect the charges on surfaces that are moving around in gold leaf electroscope. Okay, so I have my mink fur, and I have my plastic rod. I have my wool here, and you have to understand how the charges are changing and to know how to move your motor. This is pretty much the African motor, or whatever you might want to call it. So I have my resistor just in case I want to discharge and ground stuff and start from zero. Alright, these are all I got for this experiment. Gold leaf electroscope. As you can see, I set up stuff so when it moves, you will know that they are moving. So moving forward, I just wanted to show you guys something here. Over here, something moving here. Not yet. Alright, let's try again. I'm gonna rub this here, and I'm gonna move it over on this one. If not, I'm going to try this. Okay. Anyway, that's not what we're here for. So if you notice, there are some wood pieces. This is from rolls that I have. I have the tinfoil tied around them. Oh, I forgot to tell you I'm using tinfoils too. Just tinfoils to complete the close the loop, basically. That's what it's for, okay? Same thing is what I've done with the R4 that you see on top there. I don't have any battery here. In this experiment, there's no battery, so we're investigating. We're scoping out the charges to see which way they're going, and etc., etc. So, from what I've done so far in the experiment, I think perpetual motion is possible. I don't have time to show you everything back, forth, and everything. There's no battery here, period. So the law of perpetual motion that I came up with, I didn't just come up with it. I knew about God's law, which talks about magnetic flux, that the net magnetic flux is in any cold system is always going to be equal to zero. Okay. I also know about Faraday's law of electric induction. I do know that the electric field, when you take the line integral of an electric field, it's always going to be equal to negative rate of change of the magnetic field point blank. So Faraday acknowledges the polarity in the magnetic field for these two. So you get the whole picture. Now, what's interesting about Lenz's law is that he actually says that these electric field, that rate of change that you see, negative rate of change, is able to do some kind of work. That's where the electromotive force comes from, the E naught, which is equal to number of times of wire, and then rate of change of the magnetic flux. Okay, so if you look at all this and put it together, you understand that you might not need a battery to cause something to move. Let's see if I'm right. So I have this thing here. Okay, I've already read the law here for you guys. Law of perpetual motion machine states that the line of surface integral within closed loop of electric field does work by moving columns of charges from point A to point B, creating a potential difference. This voltage, which is equal to work times charges, meaning the work required to move the charges from one point to another. Altogether is equal to the negative rate of change of the magnetic flux through the line or area enclosed by the same loop. So let's see if this is correct. I'm gonna do this, and I'm gonna move it close to the little four that you see there, and let's see what happens. Okay, you moved a little bit, so I should have wanted a little bit more before I did it. There you go. It's not magic. This is science. But this is African science. Nobody talked about it. There you go. Now you know. Let's try it again and see if it's true. Okay. Okay, let's try again. It's not magic. You see? It's moving always close to the magnet. I mean, always close to the plastic. And that's what I wanted to show you guys today. Maybe I should try it the other way around and see what happens when I try it the other way around. It's moving. It's trying to get to, see? Now it reversed the other way around. You see? It's always, depending on the charges that it has, when I come close, you move the other way around. See? When I come this way, depending on the charges that I have, when I bring it close, watch what happens. I have to move, right? Once I move it, there has to be some kind of motion. See? Once I have some kind of motion, it moves around. So that's the proof that perpetual motion machine is possible. I'm the first person on this planet that have done this experiment. Thanks to YouTube, nobody's gonna come and say that they did it before I did. Alright? That's the law of perpetual motion machine. The line or surface integral within closed loop of electric field does work by moving columns of charges from point A to point B, creating a potential difference. This voltage is equal to the work done in moving the quantity of quantity of charge. Altogether, we are saying that they are equal to the negative rate of change of the magnetic flux through the same line or area enclosed by the same loop. Thank you, guys. So we've accomplished our goal. Our main goal is to encourage the continental youths to push that what they need is within themselves. They have to look carefully. There's no need to go around chasing the wind across the places. The secret is there with you. I've just proven it to you. Take care now. Bye-bye. If you want to know more, if you believe that I know a lot more than I'm talking about, why don't you join us on Each One Teach One? And also, we're about to start raising in order to pursue some of our interest in promoting science and connecting the ancient to the modern and bringing all our ancient knowledge to the modern science so we can move forward as a people. Thank you.